The points A, B, C lie on the circumference of a circle, A, B, C. The straight line PBT is a tangent to the circle, and CBP is x degrees, where x is measured in degrees. Show, giving a reason in your answer, that the size of ABC, so the angle in here is what we're interested in, is 90 minus x over 2. So, okay, so then let's work this out. This is an isosceles triangle, and this angle is x, so we need to use the alternative segment theorem. So here, the alternate segment theorem specifies that the angle here in this other segment is the same as x. So let's just take that as said for the moment. We'll come back to prove that actually in just a minute at the end of the question. But supposing that were x, then if we dropped a perpendicular, because it's an isosceles triangle, this is 90, and so these angles will both be the same. We can label them as y. Okay, so what have we got here then? We've got 2y plus x is 180, haven't we? So here, by the alternate segment theorem, angle CAB, so CAB angle is equal to x. So, or as such, x plus 2y is equal to 180. So then that implies that 2y is equal to 180 minus x, and divide by 2. Move the 2 from times to divide. 180 divided by 2 minus x over 2. So y is equal to x over 2 degrees, which is what we wanted to show. Now, how did we, if you forgot the alternate segment theorem, how would you get that? Just by looking at the triangle. Well, there's another way to just derive it, to show that that was x. So I'm just going to get rid of all this now and just show you that, just briefly at the end of the question. Here's the center, isn't it? So let's just drop a radius to the points here at B and C. This is the center then. And I'm also going to drop a perpendicular here. This is a right angle triangle, isn't it, when you drop a perpendicular here. So what have we got then? This is x. So because I've dropped this as a radius and this is a tangent, this whole angle is 90. So in here, this is 90 minus x in there. And this is 90. So this angle here must be x, mustn't it? Because x and 90 minus x add up to 90, and the 90 is 180. And then this is isosceles, so this other side is x, isn't it? Here. And so the angle at the center is twice the angle at the edge. So that would be half of 2x, which is x. So once you know that's x, which is what we wanted, that's the alternate segment theorem. But we've just gone through it using the simpler process and the properties of the circles. So I just wanted to mention that in passing. Hopefully you can remember that formula or result called the alternate segment theorem, and it comes out straight away that the angle in question that we wanted was 90 minus x over 2 degrees.